Hello, today we are going to talk about formula. Before we start, I just want to say something about the spelling. Now, formula, F-O-R-M-U-L-A, is the singular. The plural of formula depends on whether you're in the UK or in America. Now in the UK, you would say formulae for the plural. In America, you would say formulas. Alright, let's get started. Let's look at an example. E equals to mc squared. That's a famous equation in physics. This is a formula. It is a formula that relates E to the symbols M and C. Right? In this case, E happens to mean energy, M is the mass, and C is the speed of light. But we don't worry about that for now. We're just going to learn the mathematics of formulas. So what we have here is three symbols, and the symbol E is related to the symbols M and C by this equation. Such an equation is called a formula. And we say that E is expressed in terms of M and C. It is a way to help us to calculate E if we know the numbers for M and for C. So let's look at an example. Let's look at V is equal to I R. In this formula, we have three symbols, V, I, and R. And V is expressed in terms of I and R. V is actually equal to I times R. So, suppose that we are given I is equal to 2, R equals to 3. So given these numbers, we can then find V using the formula. The way to do that is to replace I in the formula by 2 and the R in the formula by 3. Right? At the same time, we must also remember that IR means I times R. Okay? So now I is 2, R is 3. We have 2 times 3, which is 6. So this is a very simple example of how we use a formula. And formulas are very useful things. They usually help us to solve problems in the real world. For example, this particular formula, V really means voltage, I is the current in a circuit, and R is the resistance of an electrical circuit, and this formula actually helps us to find the voltage in an electrical circuit. But as I said, we will look at the mathematics of this first before we go on to tackle some real problems. So let's just get a little bit more practice by looking at another example. V equals A plus ut. This is a formula. It expresses V, the symbol V, in terms of A, U and T. So that's a relation between the symbols. And suppose now that we are given the values of A is 1, U is 2 and T is 4. If we are given these values, we can use the formula to find V. All we need is to substitute the numbers of each symbol into the formula. So let's do that. V is equal to A is 1 plus U is 2. UT means U times T, so there is a times there. T is 4. So we have the numbers now and we can calculate. We have to do the multiply first before the plus. So 2 times 4 is 8. And 1 plus 8 is 9. There, we have our answer. Let's take a look at a slightly more difficult way to use formulas. Look at this formula. R is equal to V over I. Now suppose we are given the values of R, that R is equal to 2 and that V is equal to 5. And we want to find I. What is I? So like before, we can substitute the numbers for R and V into the formula. Let's do that. So R is 2, V is 5, I we want to find. But we have I here at the bottom. Okay, that's tricky. If you look at the previous example, the V, the symbol that we want to find, is on one side and the numbers we can calculate out on the other. That was convenient. Now this time we have the I at the bottom on one side. So how are we going to calculate I? The way is to use what we have learned about equations. What we have here is actually an equation. We need to solve for I. right? Now, as we remember from equations, we are allowed to multiply or add the same things to both sides of the equation so that they remain equal. And the idea is to add, multiply, or subtract or divide the right sort of numbers so as to rearrange the equation and find the answer. So let's get on with it. In this case, what we need to do is to move the I to the top somehow, okay, rather than sitting at the bottom. I'll just say what we need to do. We need to multiply both sides by I. Now the reason why this works is because when you multiply by I, the I cancels on the right hand side. And you have an I on the left hand side. So in this way the I comes up at the top. So it's a rather tricky way of doing it if you don't know. But the idea is that you look at it a few times and get to remember it, and you can do it next time yourself. So I is now on top. We want to find I. We have a 2 there. We have I times 2 there. So we want to get rid of the 2. Since this is I times 2, we can get rid of the 2 if we divide both sides by 2. Now let me write this down first. This is I times 2. That's just 5. I and I have cancelled. So now we divide by 2 on both sides. That. Two over 2 is 1. They cancel. And therefore, we have our answer that I is equal to 5 over 2. Let's look at another example. We have the equation A is equal to B plus 1 over C. Now, suppose we are given that A is 2 and C is 4. And we need to find B. In order to find B, let's start by substituting A and C into the formula. So A is 2, B we don't know, C is 4. Now we need to find b. So this is an equation with the symbol b. We use what we have learned about the equation. We start by trying to get rid of numbers on the same side as b. So let's start with the 4 at the bottom. Now the 4 here is at the bottom of a fraction. We can get rid of that if we multiply both sides by 4. Then the 4 and the 4 cancel. We are left with b plus 1. On the left side, we have 4 times 2, which is 8. It's a lot easier now. Move the 1 to the other side, so the 1 changes sign. Only b left on the right side, and therefore b is equal to 8 minus 1, which is 7. So there we have our answer. If you look at this problem, you see that we are given two of the numbers, the number for two of the symbols in the formula, and we have to find the third one. Now, what if we need to do this very often? What if we need to do it for a different A and a different C, and we need to do it again and again and again? Now each time you need to put the numbers A and C for A and C into the formula and then solve for B using these steps, using the methods for equations. Now there is a way to make things easier without having to solve the equation each time. Now the way is to rearrange the formula so that we have just B on one side of the equation. That means we can rearrange this so that we have B is equal to something. Just B on one side and the other symbols A and C and others on the other side. Now this is called transposition. And putting B on one side, B is called the subject. Just as in the previous formula here, where we have A on one side and the formula, the expression on the other side, A is called the subject. Alright, the idea is that if you have this arrangement, then it is as if this expression here, it's as if the purpose of this expression here is to calculate A. So A, therefore, is the subject of this formula, in the sense that it is the purpose of this formula. So in this case, if we need to find B many times, we can rearrange the formula so as to make B the subject. So how can we do this? We can do it simply by applying the steps that we use to solve the equation. We can just apply these steps to the formula itself before we actually substitute numbers into the A and C. So let's start and see how we do it. So starting from this formula, the idea is to solve for b, is to treat this like an equation as if a and c are numbers. So we want to find b. Alright? So think of a and c are not as numbers. We want to get rid of the c and the 1 so that we have only b on one side. So for a start, to get rid of the c at the bottom, we can multiply both sides by c. On the right side, c and c cancel. You're left with b plus 1. On the left side, we have c times a, which is ac. Now we want to find b. We want to have just b on one side. Since we have b plus 1 here, we want to get rid of the 1. We can move the 1 to the other side or subtract both sides by 1. So we have minus 1 on the left side, just b on the right side. We have subtracted 1 from both sides. So now we have b, just b on one side, and on the other side there is no b. b does not appear on the other side. That means that we have just made b the subject. Alright, so now we have a formula for b in terms of a and c. So this time, if we are given numbers for a and c, like in the example just now, we have a equals to 2 and c equals to 4. We can just use this new formula or the rearranged formula. Just put in the numbers for a equals to 2 and c equals to 4 in here, and we can find the answer. In fact, let's try that. So b is equal to ac minus 1, and a is 2, c is 4. Let's put these in. A is 2, ac means a times c, so it becomes 2 times 4 minus 1. Alright, 2 times 4 is 8, minus 1, 8 minus 1 is 7. You get 7 here. Now look at our answer just now. We got 7 just now. So we get the same answer. But in this case, it is easier. All we need is to put the numbers into a and c and calculate these directly, instead of having to put the numbers into the previous formula and then go through the steps of the equations to solve for b. So by rearranging the formula to make b the subject, we can save a lot of work next time if we want to find b. Let's look at another example. y equals to 2x plus 5. Let's try and make x the subject. This means that we want to rearrange this so that we have x on one side and the rest on the other side. So let me just write this down. So that's the question. We want to make x the subject. Starting from the first equation, we use the methods of solving equations. On the first equation, we have x on the right side, and we have x times 2 plus the 5. So let's try and get rid of the 2 and the 5. We start with the 5. So subtract 5 from both sides. We get y minus 5 on the left, and the 5 is gone from the right. So now we have just 2x on the right hand side. Now 2 times x. We need to get rid of the 2. Can we do that? We can do that if we divide both sides by 2. Now be careful. On the left side, you have y minus 5. So when you divide by 2, you need to divide all of the left side by 2 and not just the one of them. The answers will be different. Okay? Whatever you do to both sides, you do to the whole thing on each side. So 2x over 2, the 2 and the 2 cancel. We have just x remaining here. On the left is y, still y minus 5 over 2. So that's our answer. We have just made x the subject, and this y minus 5, the whole thing over 2, is the formula for x. And let's look at something slightly more complicated. Let's look at square root. Now, consider this symbol here, x. When we say the square root of x, it's easiest to understand this if we think of x as a number, for example. Say square root of 4. Now square root of 4 is 2. Right? Because square root is the opposite of a square. So we know that 2 squared is 4. That's why the square root of 4 is 2. Just to remind ourselves, 2 squared just means 2 times 2. And in algebra, we will often see the square root sign, and the way we can manipulate this, we can do things to this if we understand how it works for numbers. we can take over the ideas from numbers in algebra. So for example, let's go back to the numbers. You've seen that 4 is the same as 2 times 2, and that the square root of 4 is 2. Okay, I seem to be repeating myself here, so bear with me. So the 2 there is the same as the square root of 4. So let me write it down here. What you see here is that the square root of 4 times the square root of 4 is equal to 4. Now that's a new way of looking at it. When you multiply two square roots together, you get back the number. I can also write this in this form. 4 is equal to the square root of 4 whole thing squared. Now this may seem a bit redundant and useless even, but it becomes quite useful when we do algebra. Look at the square root of x there. Multiply square root of x by itself. What do you think the answer is? It is not very obvious just by looking at this, but if you look at what we do with numbers, square root of 4 times the square root of 4, you get back 4, then it's quite obvious that root x times root x is x. And we can therefore also write this in this way. Alright, square root of x, whole thing squared, is equal to x. So these two expressions are quite useful if you get used to the fact that they really mean the same thing as x. So as an example, suppose we are given this formula and we want to make C the subject. Alright, let me just write this down. That's the question. We want to make C the subject. The way to do it is to apply the ideas here. That if you have a square root, when you square it, you get back the thing under the square root sign. Now we have the C there, the C is under a square root. So in order to make C the subject, in order to put C on one side of the equation, we must first get rid of the square root. And we can do that by taking the square of both sides, like what we did there. So this is what it looks like. If I take the square on both sides, square of the left side is a squared, and we must take the square of the square root. Now that looks a little complicated, but if you compare it with that, it's the same sort of thing. If you take the square of the square root of x, you get back x. So if you take the square of the square root of BC, you should get back BC, which is everything under the square root. So this is a squared equals to BC. So let me write that down again. We now want to make C the subject. The right side is B times C. We only want the C on one side, not the B. So get rid of the B. To get rid of the B, we divide both sides by B. So if you do that, if you divide the right side by B, the B cancels and you're left with C. If you divide the left side by B, you have A squared over B. So that's the answer. C is equal to A squared over B. Now we have C as the subject.